People find path analysis tricky, so this is my attempt to demystify it. Now look, there's many ways of doing path analysis, so just be aware that this is the one I like, or the one that gels with me. So you might need to look at a few videos to find one that you kind of like. Okay, so this method works such that what we do is next to each of the vertices we place one of these boxes. And last one. Okay, and now what we'll do is we're going to use, or in these boxes, we're going to write the start time, the earliest start time and the latest start time, the EST and the LST. So let me just change the color of my pen, and what we'll do is we'll do what's called our forward scan, and indeed we'll write all of the earliest start times of the activities. Now this is the start activities, start A, so the earliest we can really start that is 0. We need to get that going straight away, otherwise it's going to delay the whole project. Alright, so then what we do is we look at task B, okay, and the earliest we can really start task B is 3, because A needs to start at time 0, and it's going to take 3 days or 3 hours, whatever its duration is. So we do 0 plus 3, and we get an earlier start time of 3 there. Okay, so it's the same with C and it's the same with D. The earliest we can start all 3 of these tasks is in fact 3. Alright, let's keep going forward and write the earliest start time of F. The earliest start time of F is actually 3, which is the earliest start time of B, plus its duration, which is 5. So the earliest start time of F is 8. Alright, down to here, okay, and what we do is we look at the earliest start time of G. Now, I actually can't work that out yet because I need to work out how long these arrows here will take. So all I'll do is I'll look at and write down all of the lead-in arrows or the lead-in tasks or the predecessors. So there's F, D, and E. Okay, and what I'll do is I'll write down the duration of F just for the moment. Okay, which is 8 plus 6. So F will be 14. Alright, now we look at D here, and D will be the earliest start time of D is 3. 3 plus 9 is 12, so I can write a 12 there. Okay, and finally, let's go down the bottom here. So we've got an earlier start time of 3, of 3, and 3 plus 4 is 7. So the earliest we can start E is 7. All right, now again, let's look at 7 plus 6 and write down the number 13. And what we do here is, it's a little bit tricky. We've got 3 possibilities to write in this box, and what we do is we put the largest number in the box, okay? Because essentially what this is saying is that the 14 is the earliest we can get task G going, because actually the longest task, or the longest group of tasks coming into G, will take 14. These other ones have got 12 and 13, which means that they've got what we call a little bit of slack time built into them. That is, that these tasks leading in from D can be delayed by 2, and these ones here can be delayed by 1. And we'll check that out a little bit later. Alright, so to finish this forward scan, it's pretty easy. We just do 14 plus 4, and I've lost my pen, so I'm just going to bring that back up again. Where is it? Review and pen, and write the number 18 in there. Okay, now what we'll do is we'll go ahead and do our back scan. So I'll change color to blue. Okay, so to get this going, simply write 18 in there. Now, to work out the latest start time of G, I simply do 18, take away the task duration, which is 14. Alright, now do the same thing going back through here. So we do 14, take away 6 is 8. Okay, now if we continue back here, I do 8 take away 5 is 3, but have a look at what's happening with B. Okay, there's at this point here, there's actually 3 arrows or 3 tasks coming out from A, okay, or that depend on A. So what we do is we use a similar approach to the forward scan. We look at the tasks coming in. So there's B, there's D, and there's C. And I know 8 take away 5 is 3, so I write down a 3 next to B, okay, and that number's yet to be determined. Alright, going back through, I'll write 14, take away 9 is, what is it, 14, 10, 4, 5. Okay, so D will be 5. Okay, just struggling with the old basic arithmetic there. Now, coming back down the bottom here, we've got 14. We'll do 14 take away 6 is 8. 8 take away 4 will be 4, so I write down a 4. Now, it works a little bit differently to the forward scan. Remember, with the forward scan, what we did here was write down the largest possible number in that box there when you got multiple tasks that are predecessors. Well, in this situation, so we say that, I've heard the saying, largest number goes in the box. This time what we do is we put the smallest number in the box when we do the back scan. So a 3 will go in here. Okay, then to finish this off, I do 3, take away 3 is 0. Okay, so now I've completed my forward and backward scan. I can now go to the table down below here and start to fill it in. So let's just change my pen color again, because that's kind of fun. So review, where's my inking, and let's choose good old-fashioned black. Okay, task A has a duration of 3. It doesn't have any predecessors. The earliest I can start it is 0, and the latest I can start it is 0. It has no slack time. It can't be delayed. All right, task B. The earliest I can, its duration is 5. It does have a predecessor of A. The earliest I can get that task going is 3. Okay. Now, to get the latest start time, what I do is I look at this box here, and I look at the latest start time of F. I do 8 take away 5. That gives me a latest start time of that task of 3, which means there's no slack time in that one as well. Okay, coming through, let's do now task C. Task C's duration is 4. Its predecessor is A. Alright, now let's do the earliest start time of C is also 3. The latest start time, remember, is this LST take away 4, okay, which is 4. That actually has slack time of 1. That basically means this task can be delayed by 1 day, 1 hour, whatever the duration actually is in the context of the question, and it won't affect the overall finishing time or completion time of the project. Alright, let's go to task D. Its duration, the longest task is 9. Its predecessor is also A. The earliest I can get that going is 3. Now remember, to get the latest start time, we do 14, which is the LST of this task here. Take away 9 is 5. Okay, and that has a slack time of 2. Alright, task E. Its duration is 6. It depends on C being completed, and the earliest start time of E is 7. And to get the LST, we do 14 take away 6 is 8. We've got a 1 for the slack time there. Alright, almost there. So we've got F. F's earliest start time, F's task duration is also 6. It depends on B. Earliest start time was 8. 14 take away 6 is 8 as well. We've got a slack time of 0. Alright, the last task was G. Its duration is 4. It's got a lot of tasks it depends on. F, D, and E. All of those tasks. Alright, the earliest I can get that going is this time here, 14. The LST is given by doing 18 take away 4 is 14. It has a slack time of 0. Alright, the critical path. Pretty easy to obtain once you got one of these tables or done the forward and backward scan. All we look for is tasks with no slack time, and they are on the critical path because any delay in those tasks will result in the delay of the project. Alright, so from the table we can see that A has no slack time, so we go from A to B, because B has no slack time, to F to G. Okay, and we can draw that straight onto the diagram. Review, let's change color one last time. We'll go with a highlighter actually. Color, let's go yellow. Okay, so A will be on the critical path, that task there, up to there. So you can see here I'm just basically looking for the vertices where the earliest and the later start times of the task that's after the vertex is the same, and there. That's our longest path through the project. Right, the last question, the minimum completion time. Well, the minimum completion time is simply this time here, which is the earlier start time or later start time of the finished. So the minimum time for completion is 18 days or 18 hours or whatever, again, the duration actually is. Alright, so that's how I do a forward and backward scan. That helps us get these tables, and this helps us get the slack time for all of the tasks.